policy series on energy infrastructure. Our next session deals with smart energy infrastructure, leading from cyber and the technology involved with that into automated metering, artificial intelligence, and much, much more. Our moderator for this session is MEI board member Kim Winslow, Senior Director Energy Solutions at Evergy. She will be moderating this session and leading a great panel for us to hear about what's going on now and how people are working together. Kim, I hand it over to you.
Great, thank you, Josh. Appreciate it. Well, good morning, everyone. And as Josh said, welcome to the Smart Energy Infrastructure session. During this session, our speakers are going to focus on the policies, research, and implementation of smart technologies, including those AMI meters and artificial intelligence in the energy sector. As you're aware, AMI deployment, it's been occurring, quite rapidly, at least in Missouri, what I'm more specifically knowledgeable about over the past several years. And there is a lot of opportunity to utilize the AMI meters, think about it from a planning perspective, a products perspective. So I'm really interested in learning more about what our speakers have to share with us today. So we do have three very experienced speakers that I'd like to introduce to you. David Schomber is a senior product manager with Landis & Gyr. He is with the Next Generation Electric Metering Platform. Prior to joining the product management team, David spent 10 years working in Landis & Gyr's manufacturing and engineering teams, developing firmware and software for the residential, commercial, and industrial and grid metering product lines. So welcome today, David. And then we also have Yoni Pepinen from EPRI. He is a technical leader with EPRI, where in 2016, he joined the Power System Studies group there at EPRI, and his research focuses on advanced methods for power distribution system modeling, analysis, planning, and operations with high penetrations of DER. And welcome, Yoni. And also we have Shelby Linton-Ketty with EEI. She's a senior director under state energy and regulatory policy. Shelby serves as the senior director, where she oversees EEI's national engagement and strategy on state regulatory issues before public utility commissions. So with those introductions, again, welcome panelists. We're going to have David start us off, and he'll be going over some of the trends and applications related to the high-speed sampling and edge intelligence. And Yoni, he will then dive into some of the research that he has been doing with EPRI on distribution planning and modeling. And Shelby will close us out on where to look at where smart meters are and aren't from the policy perspective, as well as discuss some specific case studies. We're also going to have an opportunity for questions following their presentations. So, make sure that you submit those in the chat form. But anyway, look forward to hearing more from each of our panelists. So right now, I'll pass it off to David.
Thank you, Kim. Happy to be here this morning. I'm going to kind of go through some of what the future looks like with smart metering and cloud computing, AI, machine learning, how we see all these things kind of merging together. So these are all things we've used, experience in our daily life anymore with things like our smartphones and all the different applications that have come into that space that are far beyond what a phone was ever designed for originally. We're seeing the same thing as we move into smart metering, the next wave of the technology. And I'm going to kind of walk through some of the benefits we see direct to consumers, especially. I'll go advance. So when we talk about high resolution data, what does that mean? If you look, these two graphs are very similar at the first glance. On the left side, we've got a load profile graph of lower resolution data. This is even high resolution by comparison to many AMI meters today. You're looking at something like 1 second data on the left, but on the right, it's definitely a sub-second data. And even this is still coarser than what we're really seeing in the next generation of electric metering, where we're really getting into sub-cycle level resolutions of data. And when you zoom into that data farther and farther, you see more details than you would have known were there with just the kind of coarser interval data that we have today from our AMI meters. And you can actually start picking out signatures of appliances. You can see, power quality issues and other, gain other insights that may be occurring either behind the meter, in the home or in the business, or back looking into the grid, and like I said, things like power quality monitoring. All right. So one particular application that's really exciting with this technology, if you've heard of Sense, you may have seen this before. They're taking this high resolution data and they can actually pick out the signatures of those appliances. And the importance of this is the real-time element of it. And this is really where the industry is going, and it's going to really increase engagement with consumers. And is something that I think is lacking in the some of the AMI like 1.0 technologies we've seen. And this really drives things like consumers being able to save money on their bills, because they're actually seeing real time what is my energy consumption right now. How can I translate my usage right now into dollars and cents? Maybe a kilowatt hour isn't just kind of an abstract concept for many people, but seeing, okay, all of these, appliances, my dryer is costing me $1 per hour or something, that hits home and people understand that. But beyond that is really just, giving insights into what's actually going on, what is using energy, but, even how is my home behaving? How are the people in the home? What are they doing? Did my kids leave the lights on somewhere that I didn't know about? Or is my refrigerator running a lot more than it should be? Maybe there's a potential issue with that, that I need to look into, because that could result in a failure to the equipment. But then more importantly, you could lose everything in that. If you lose a chest freezer full of food, that can be a big detriment, both financially and just in terms of security. And then lastly, having this accessible at your fingertips, an interface like on a phone or a web application, now branches out beyond just your meter and the ability to integrate with other devices and start to build out that smart home experience where it integrates with smart plugs for doing demand response programs and other automation. Okay. So again, the big thing here is this really drives engagement, because it starts to appeal to people at more of the personal level of, how does this affect my life? How is this tailored and designed for me? And that's where the AI comes in and the machine learning, because now, like we see in a lot of other, avenues with the internet and with our phones, you see that tailored experience, whether it's through advertising or your interests on news or, social media. The same thing is an important element to energy management, making this personalized, helping manage, whether they're trying to save energy or they just want to know what's going on in the home, of being alerted to potential concerns like the oven in this case being left on, take that off my mind so I can go think about other things, and let me know, did I leave my oven on for 2 hours, which might be a problem. Okay. And this also, from a utility perspective, really does help with the adoption of time varying rates, time of use rates, demand rates, those kinds of things, because again, you get to see a dramatic, an immediate effect, and you can reach out to your consumers, to your customers, where they are, on their devices anytime. They can opt in with these, these rate plans. At the click of a button, it doesn't require phone calls, doesn't necessarily require logging into portals that they reference periodically. Instead, it's right there, and you can see again the immediate impact of that change, instead of having to wait 30 days or 60 days for a billing cycle to see the real impact. Right? And so this is a couple of just kind of testimonials to this technology and how it's really helped people. There's a whole host of different use cases. Again, it's tied to energy, but it's beyond that. It's really, what's going on in your life, managing your lifestyle, finding things that might become bigger problems later. Finding things even like, in one case, there's a testimony out there about a guy who found that his meter was actually not tied to his home. The account he was being billed from was actually his neighbor's house, which from month to month, it might look pretty similar if the homes are the same size and same number of people in it. But then looking at this technology where he was able to see, okay, well, it's actually running and when, he realized he wasn't looking at his meter. He wasn't getting billed for his meter. He was getting billed for somebody else's meter. So there's a lot of applications beyond just your traditional save money on electricity. Right. And yeah, so this is technology that's still a little out in the future in terms of AMI metering, but it's coming very rapidly. It exists in the market as consumer devices that can be purchased. There are utility programs out there that are offered as well. But we are seeing this scaling out to, like I said, the next generation of metering technologies, which are really bringing the ability to sense at a much higher resolution data than we've seen previously, as well as offering edge intelligence, AI and machine learning at the device in the meter, and the ability to host custom applications to integrate with the devices that are in our lives, like our thermostats or our smart plugs or EV chargers, and giving control of that to the consumer. Right. And kind of lastly, so benefits to the utilities, they're numerous as well. I didn't touch on them too heavily, but a lot of them are operational, whether it's customer service, managing high bill complaints, reducing those, getting more people to take up energy assessments and try to improve the efficiency of their home, getting further adoption of demand response programs, and actually getting people to react to the demand response events that are being pushed out, getting higher reaction to that, and benefiting more than for the utility to reduce their peak demands. Optimizing EV charging, that's a big one that gets talked about a lot. So if a whole neighborhood were to buy EVs all at once, that would put significant strain on the infrastructure in that location. So being able to optimize when people are charging and giving them insights into why that's important is a big one. It's not just about convenience of when they charge or anything, but why their choice of charging time has an impact to them and their neighbors. And then lastly, analytics, power quality monitoring, real-time data. This is really a big one when you start looking at reliability for the consumer. If you're looking at commercial accounts, that can be even more important if there's manufacturing going on with sensitive equipment. So these are all benefits to not only consumers, but the utilities. Thank you.
Great. Thank you, David. Appreciate that. Well, we will now then move over to Yoni to present.
Thank you, Kim. Can you all hear me well?
Yes.
Perfect, perfect. So I will be talking a little bit about AMI and other data and their applications in distribution operations and planning. Can I have the next slide? Just a high-level overview of EPRI. EPRI is an independent nonprofit collaborative research organization, 450 participants in more than 30 countries. 90% of electricity is generated by EPRI members in North America, and a lot of international representation as well. Let's go to the next slide. So EPRI does research across the entire electricity sector, from generation, nuclear power, power delivery and utilization, to energy and environment. I personally work in the EPRI power delivery and utilization sector, and more specifically in the distribution operations and planning research group. So my presentation here today will be kind of focused on distribution operations and planning and different applications of AMI and other data in that domain. Let's go to the next slide. Let's start with the brief motivation here. Can you, yeah. So starting here, there's a lot of things happening at the distribution level for distribution utilities. Conventionally, distribution operations and planning was subject to few distributed resources. There was limited autonomous controls at the distribution level, limited monitoring and visibility, and as a result, a lot of the planning and operational practices had limited reliance on models. So there was limited need for accuracy and detail of those models. Now, going forward, that's changing rapidly. So can we advance here? So in the future, distribution operations and planning will be subject to increased penetration of the DER, which is really the key driver for a lot of other things happening at the distribution level. There will be much more enhanced and hybrid centralized control schemes, a lot more data coming in, providing a new level of visibility, and things are becoming much more model-based. There's many more model-based applications that really motivate the need for increasing accuracy and detail of those models. So what's the role of the data here? Data is really the enabler, or one of the enablers in this transition from these conventional practices to these future practices in distribution operations and planning. Let's go to the next slide. So there's a lot of things that you can do with the data. AMI and other data can really enable and support many applications in distribution operations and planning. Here's just a non-comprehensive list of some of the applications that we have seen at EPRI for AMI data and other data in distribution operations and planning. Really going on for more detailed modeling of loads, DER generation, using the data to calibrate models, to perform more detailed assessments, identify outages, visualize voltages, use the data as a feedback for control schemes, identify misoperation of equipment, and so on and so forth. There's many applications. I don't have the time to talk about all of this today, so I will focus on 4 applications that I have been working personally at EPRI. So let's go on. Next slide. So here are the 4 applications that I will focus my presentation on. Let's start with the load and DER modeling. Let's go to the next slide. So distribution utilities have performed load modeling since the dawn of electrification. So the question here is, what's new? What's the deal here? Well, obviously DER here, as in many other things, is really the driver here. Things are becoming much more model-based decisions and applications. Utilities are increasingly looking into other conditions, system conditions, than the peak load. In the past, planning decisions really were driven by the peak load conditions, but as there's more and more DER, it becomes more and more important to look at other system conditions as well. And then as utilities are deploying these operational tools, such as advanced DMS systems, those tools have modeling requirements and capabilities that involve also load modeling. So the role of the data here, AMI and other data, is that it really provides this new level of visibility to load and DER operation at the distribution level, as illustrated in the diagram there on the right. Let's go to the next slide. Let's advance here a little bit. All right. So the challenge here really is that there is much more data, and there is so much of the data that it's, if you compare to the conventional load modeling data that utilities are using, AMI is really increasing the amount of data in the order of 2 to 3 orders of magnitude. This is really a challenge by itself. So on the right-hand side, you see an example of a project we had at EPRI analyzing an annual AMI data from roughly 33,000 premises. So this is just a small subsection of a distribution utility service territory, just a dozen feeders or so. But this data set was in the order of 50 gigabytes. Compared to conventional data sets that would be a couple of megabytes. So just to understand, like, that amount of data, it becomes much more challenging to work with that data. So I want to emphasize here that having access to the data is really not enough. What you need is also tools, methods, and skills to efficiently and effectively leverage that data for the various applications. The question, of course, is it worth it? There's a lot of effort involved, so is it worth it? The value of the data really depends on the application. There's many applications, and the value depends on the application. In terms of load and DER modeling, what we have seen at EPRI is that the value really tends to increase as you kind of move from the aggregated customer level to individual customer, kind of like towards the grid edge. As you perform more detailed assessments, as you analyze higher DER penetrations, or as you assess these more advanced control schemes. That's really where the value of this data in load and DER modeling comes in. Let's go to the next slide. So that was the first application. Let's talk about the second application, which is the model calibration. Let's go to the next slide. Let's advance here a little bit. So as I already said, there's this increasing need for more accurate and detailed distribution models. The challenge is that even if there's a need for these models, in the past, as the models were not so extensively relied on, there is a lot of challenges in those models. The models are subject to a wide range of different issues and errors, that some of which are illustrated in the diagram here on the right. It can be quite challenging, really, to keep the models up to date and accurate and detailed. So the promise here, or the potential here, is that AMI and other data can potentially support and enable different applications to calibrate these models. Let's advance a little bit more here. But however, to do that, what you really need is tools and methods to leverage the data, to identify where those issues and errors are, and then identify how to potentially correct for those errors. And there's a lot of research happening in this area in different applications of leveraging the data to calibrate distribution models. Let's go to the next slide. So here's just a couple of examples of the specific applications that you can use AMI and other data to calibrate the distribution models. You can use the data to identify and correct for errors in the Geographic Information System, GIS. Errors such as incorrect phasing of service transformers, incorrect mapping of customers to service transformers, and things of that nature. And as you kind of need these more detailed and accurate models, correcting for these errors becomes really quite important. Another example is you can also use this data potentially to even generate sections of distribution models that in the past were not included in the GIS or in the planning tools. You can, for example, generate the low voltage circuit models that are becoming increasingly important as you have more and more DER connected at those low voltage circuits. You can also potentially use the data to identify and correct for different types of DER information, such as interconnection locations, nameplate ratings, and things of that nature. All right, so that was the second application. Let's move on to the third application, which is the DER impact analysis. Let's go to the next slide. So as the DER penetrations are growing, there's really need for more granular approaches to analyze the impacts and the value of this DER. Again, the role of the data here is that it can support and it can enable these more detailed assessment methods. Here on the right, you can see an example illustration of an EPRI project that was evaluating the impact and value of PV smart inverter functions. The value and impact of these functions and DER in general, it really depends on a myriad of different factors. And really to understand properly those impacts, more granular assessment methods are needed. Let's go to the next slide. Let's advance here a little bit. There we go. So this is just an illustration of how the kind of conventional DER impact analysis methods are evolving. So on top, you can see kind of an illustration of conventional approaches that are really focused on analyzing specific system conditions, peak load, maybe the minimum load for DER impacts. Loads are modeled based on SCADA data at the feeder head substation, allocated to the customers using different methods. DER is modeled based on nameplate rating or other kind of worst case criteria. Now you're moving more into this more granular analysis approaches, things like time series analysis that can really allow you to understand more in a more detailed fashion what the impacts look like. For example, as the PV generation is ramping up in the morning and ramping down in the evening, and what the impact of smart inverter functions is and how they are coordinated with the conventional voltage regulation equipment and things of that nature. To do this type of assessments, the data can really allow you to represent the customer load conditions using AMI data. If available using DER generation measurements, you can represent in much more detail what the DER generation conditions are. And that allows you to really get much more comprehensive and granular view of the DER impacts. Again, to do this, you need much more data, but there's obviously also much more modeling and analysis effort required. So there's that question, when is it necessary to use these more detailed analysis approaches, and when these kind of conventional or more simpler approaches are sufficient? All right, let's go to the fourth application, which is a non-wires alternatives. Let's go to the next slide. So this is there's a lot of discussion now across the industry on non-wires alternatives. There's increasing interest to consider these alternatives to these distribution projects. Things like using energy storage to defer investments in substation transformer bank. The challenge with non-wires alternatives is that this consideration of them and comparing them to the conventional solutions can get quite complicated. It can be challenging to represent the characteristics of the resources, their energy limited nature of some of the resources, the controls. Sometimes these non-wires alternatives are considered also for other applications, say using an energy storage system also for wholesale market services. All in all, again, data here is an enabler. It can allow these kind of detailed assessments of non-wires alternatives, but to do that, there is need for integration of the data sets, tools, and methods to really perform this comprehensive analysis and assessment of non-wires alternatives. All right, let's go to the next slide. So let's really summarize. There was kind of 4 applications that I've been personally working on at EPRI. There's a lot of research going on at EPRI and outside of EPRI in all of these applications and the other applications that I kind of listed in the first slide there. But let's summarize kind of the key takeaways here. So the proliferation of DER, the control strategies, the model-based applications, and so on and so forth, they require this more detailed and accurate distribution models and more advanced assessment methods. Let's advance here. So again, the AMI and the other data is an enabler. It can enable and improve and support these applications in distribution operations and planning. Again, the value of the data, it depends on the application, the assessment objective, and so on and so forth. There's definitely value. The question is, where is most of the value and so on. Let's advance here. And again, I want to emphasize that having access to the AMI and other data by itself is not enough. You also need the tools, the methods, and the skills to efficiently and effectively leverage the data in these different applications that I have introduced here and others. And the last one is that there's a lot of research going on in these areas. There's research questions, things like, what are the future-proof characteristics of AMI? If you're deploying AMI today, there's many more things you can do with that data in the future beyond the customer billing. What do you need from the AMI to allow and make sure that your AMI system is going to be future-proof for those applications that you can use the data for? What are those tools and methods that you can use to effectively and efficiently leverage the data in these different applications? And what is the value of the data in these different applications? Which applications have most value? What are really the low-hanging fruits to provide the most value? And that really summarizes my presentation. I think I'll pass here back to you, Kim.
Oh, thank you very much, Yoni. That was, I myself have a lot of questions to follow up with you, but let's hear now from Shelby. So Shelby will talk about AMI from the regulatory and policy perspective. So, Shelby?
Thank you so much, Kim, and thank you for having me. Really what I want to do before I start is just give the normal disclaimer that even though I'm here on behalf of EEI, some of what I say today may be my own thoughts or opinions. One of the things that I was able to do before joining EEI is for 5 years, between 2011 and 2016, I was counsel for then Commissioner Pam Whitmer of the Pennsylvania Public Utility Commission. And so smart meters and this whole subject is something that I'm very familiar with on the commission side. So there may be some insights from there. Next slide, please. Kind of like what Yoni did, just a high description of EPRI. I'm going to just give you a very, very high description of EEI. If you are not familiar with us, we are the association that represent all U.S. investor-owned electric companies. Our members do provide electricity for more than 220 million Americans, and we operate in all 50 states. So for this first slide, when you talk about where we are going, I mean, certainly we're in the middle of a significant energy transition. I mean, we hear things from the administration all the time. If you look at some of the initiatives our member companies are pushing forward, what you're going to see is, at least for what we think, you're falling into these 3 categories: cleaner, smarter, and stronger. So what we're trying to do as an industry, and our EE members in particular, is try to get as clean as we can, as fast as we can, while keeping affordability and reliability front and center for our customers. So next slide. So just kind of going with that, I thought it would be helpful just in light of the things that this group's been discussing over the last 2 days and even right before. If you look at our industry priorities, certainly a lot of the things that are on this list were already kind of talked about by David and Yanni. Looking at clean energy, smarter energy infrastructure. So not only from the AMI, so for us with the consumption information, but certainly how is that being interacted with on the distribution side, and then certainly from the customer side. Grid security and resilience, we spent an hour and a half this morning talking about that exciting topic, so we don't need to cover that here. And then the only other one I wanted to highlight before we really dive into smart meters and AMI penetration is innovative customer solutions. And David did a wonderful job, really talking a little bit about the potential of where we can go. I do tend to agree with him. I think he alluded to this, but didn't flat out say it. But I mean, I think we do have a far way to go to be more interactive as a regular course rather than it being more of an anomaly and then more of just a one-off, like 1 or 2 companies are really far ahead while everyone else is kind of catching up. So next slide, please. So in looking at AMI and then looking at the penetration, where we've been and where we are currently, I do apologize that this slide is a little small, but if you look at the bottom left, that starts at 2011. There were 27 million AMI. I mean, just for figuring out the scope and scale and the timing where we've been. In 2008, there were 4.6 million smart meters in the US. And then as you can see in 2021, we are projected to have 115 million. And so then if you look at that infographic on the right, we have a research arm, part of EEI, our Edison Foundation, and they get this information yearly. Sometimes they do include case studies. So if you look at the IEI website, if you look at 2019, there is a report, but for 2020, they have this infographic. And what you'll notice is the places in orange, if you can't read those numbers, is that everywhere in orange is 50 to 100%. The blue indicates, I think, 15 to 50%, and then the gray is less than that. So, I mean, even though you look and you see like the trend is going up and certainly the penetration is happening, I think some people think, okay, well, mission accomplished. We have AMI. All right, what's next? But, one of the things I want to say is both from a regulatory perspective and also from a functionality perspective, I don't think we're quite there yet. And we're going to talk a little bit about that. But before we advance to the next slide, one of the things I do want to point out, and one of the things that I know from personal experience, in Pennsylvania, for example, that we had a law that was passed in about 2007, 2008 timeframe that required all of the investor-owned utilities with 100 or 1,000 more customers to put in smart meters by 2020. There was no opt-out provision, and we'll talk about that a little later. But one of the reasons why I wanted to bring that up here is because one of the companies, Pico Energy, who is one of the Exelon companies, they, were one of the first for widespread penetration, and that's because they took advantage of a federal program at the time. If you guys were around, the American Recovery and Reinvestment Act of 2009, and one of the things that ERA money did for utilities and others that were able to get that money is really jumpstart this. I believe like Pico, they were able to secure more than $100 million and get smart meters for almost 1 million customers. I think theirs were put in, I think by the 2012 timeframe, which significantly helped everybody else in the state too, because when we talk about some of the regulatory, I don't want to say obstacles, but issues that arise when we're looking at the granularity of data, how both the companies and customers are using it. It was good for us to have an example and somebody kind of going ahead so we could iron out some issues as we're going forth. So next slide, please. So, even though, again, like there's a lot of orange on that map, and as we just said, we have about 120 or give or take million AMI either in place or in progress. there's still a lot of blue on that map, you know, not only in the Midwest where you guys sit, but then also I'd say in the Pacific Northwest. And, you know, one of the things that I do want to point out and talk about a little is where we've had, I'm going to say some regulatory instruction on what kind of showing is needed now versus what was needed in the 2007-2008 timeframe. You know, so for us, for today's just distribution system, and I mean, I think it's obvious not only as someone from EEI, but someone who's been in the industry for more than 15 years. You know, I think for today and really tomorrow's distribution system, AMI is foundational. And I mean, the way that I think about it is with the 3 R's for reliability, for resiliency, and then for moving forward with rate design. And so again, not to go over what we've already heard from both David and Yanni, but, you know, clearly from the distribution side, there's benefits on finding out more information for outages, for notification to customers, for voltage regulation, pardon me, for restoration. You know, that helps both with maintaining reliability, for resiliency. You know, I think Yanni's work, and Kim, I join you with always having a lot of questions and really seeing how we can drill down and what kind of insights we can get from the granularity of data that we aren't used to having. I mean, same thing with what David's saying. And I'll talk about the customer aspect on the next slide a little bit. But well, you know, what we're kind of saying, and when I say that the standard of review has changed, I'm looking from when I first started hearing about smart grid in the 2007 timeframe to now, and my brain kind of goes to, you know, it used to be more of a Kevin Costner aspirational field of dreams. If you build it, they will come. And then my brain, and I don't know why I keep gravitating towards Janet Jackson, but my brain goes to, it's more like, now, Janet Jackson, what have you done for me lately? So that's really, you know, where I think we're going. And so what I wanted to talk about with this group is just kind of highlight 2 or 3 without giving which companies or which states 2 or 3 denials, and what I'm kind of seeing when the commission is telling you things. I mean, the first one's easy. And again, this is my own opinion, and I know that we sometimes do this as commissions. But, you know, the first one's easy when the commission just gives you 2 lines in an order saying, well, the burden of proof wasn't met. There are too many costs. We don't see enough benefits. And then that's the only information you're given. So, I mean, in some cases, we're seeing denials in states with very, very little explanation, but always without prejudice. So we're always able to come back and make our case again. So that's not necessarily helpful. Then I'm going to say we get to the more midterm, middle of the road, where sometimes, you know, we have other commissions, and without saying what state, I'll just say this is more towards the eastern coast of the country, where we have certain commissions that are really, they want to see short-term, long-term, and immediate benefits. And what I'm saying by that is, you know, when we used to be more the Kevin Costner, like in Pennsylvania, I worked at the commission again around 2011, but when we were looking at like the late 2000, like to 2007 to 2012, you know, I think it was understood at that time, this is a new thing. It's going to take time. Like even the rollout, again, a lot of these programs are approved in 2012, 2013, but it's a 5 to 7 year implementation plan. So, you know, there's a clear understanding that you're not going to have smart meters fully in until about 2020. So we weren't necessarily, at least with our commission, we weren't expecting immediate benefits, but we were hoping that those would come, you know, after the fact, obviously, to maximize the customer's benefit. But I mean, what we're seeing now, because, and I don't know if it's because we've had some states that are further ahead, they've had smart meters in for some time, and we'll talk about maximizing the value when I get to the next case. But what we are seeing is like kind of a middle ground, and what we have are some commissions that what they want is not only implementation of smart meters, but then from the customer side, they already want a rate design that customers can immediately take advantage of if they want. And again, this is a personal opinion, not from when I worked at the commission and not when I was at EEI yet, but when I worked for one of our member companies. You know, I think having rate design is one issue, but implementing a new rate a lot of times not only takes different calculations, but it takes billing changes. And the one thing that I think a lot of us in the industry know is the one thing that is not usually immediate is any sort of billing change. And so I think that we as an industry, I think we work to try to get those benefits immediate or more immediate. But we do have to set expectations with commissions in particular with what it actually takes and the timing involved in order to make that happen. And so the third one that I wanted to let you guys know about is, again, that trifecta of the need to show short-term, long-term, and immediate benefits once you have AMI. So what we're seeing, and this is more from the western side of the country, you know, we do have 1 or 2 cases that have been decided in the past year or two that rather than giving recovery of AMI outright, what they will do is defer the AMI spend, wait, and again, understand that installation will take some time, but they will reserve the prudency evaluation until AMI is installed and customer benefits can be presented. And in that case, you know, really what I wanted to bring attention here is more, this is where my brain got to the Janet Jackson. What have you done? Is because in a particular case, there was a utility dive article from January of 2020 that summarizes a study that was done by ACEEE. And essentially what this utility dive article indicates is that most utilities are not getting full value from smart meters under their existing AMI capabilities and attendant benefits. And so really what that report does and what this article highlights, and surprisingly to me, this is the first time that I have ever seen the commission reference, I'm gonna say more of an industry type article as a reason why they're deferring an asset. So this utility dive article was actually referenced as part of this order. And really what they want to see is how the company is going to be able to leverage AMI data on the following 6 use cases: having time of use rates, having real-time energy use feedback for customers, some sort of behavior-based programs, 4, data disaggregation, 5, grid interactive efficient buildings, and then 6, either CVR or volt-var optimization. And so, you know, again, the thing to let you know here is even with reporting after the fact, whereas before I think we were able to talk a little more in generalities and be aspirational, I mean, commissions are really getting to, they want to see where the rubber hits the road. What are you doing for customers? How is that really turning into benefits? And they want metrics and information that demonstrates actual benefits to customers. So next slide, please. And you know, that's just talking about one aspect to me of AMI, even though that one aspect included 6 different categories of things you have to prove. But I mean, additional issues raised with AMI, and actually, even though I have this slide, there are 2 more that I want to say, is, you know, when you have AMI, customer and system data access definitely come front to mind, not only for the benefits that David was pointing out, but I can tell you again, based on my Pennsylvania example, for all the benefits and granularity and helpfulness that some customers see, it scares other customers. And that is one of the reasons why customers don't want this technology. And so then that kind of leads into opt-out. Should you have one? Should you not? What, you know, how expansive should that be? You know, customer education and engagement, not that it's not important for all programs, but I think it's particularly important for AMI. And when I say customer education and engagement, it's really at all stages. It's not only what's your plan, it's also educating customers what can and can't these meters do. When are they going to be coming to your area? And again, literally what's going to happen if a customer refuses the smart meter? Then what do you do? You know, is there an escalation process? Do you have to get to a formal complaint stage? You know, these are all things you're going to work with. Impacts to income qualified customers. You know, I think that as we're seeing more about energy justice, about equity and equality in the services that we provide, you know, certainly I'm not saying that you always need to have a specific carve out of programs for income qualified customers, but I mean, I can tell you when we have AMI and utilities are looking for synergies, you know, to save a truck roll, do an instant connect, disconnect. There are some concerns from the consumer advocate community that we're going to be using it inappropriately, or to make sure that you're still doing the in-person notifications before you have to do a disconnect. You know, just making sure, again, the customer education and engagement and the standards and billing practices and the disconnection and reconnection rules are still in place, even though albeit differently due to technology. And then cost overruns and changes in timeline. You know, I think that, again, anyone who's done a project around their house knows that very, very often there are added costs that you didn't anticipate, or something that gets your timeline off a little bit. And then how do we, number one, communicate that to the regulators and the other stakeholders? And then at what level do we need to come in, you know, whether it's a full blown proceeding or something small. The second thing, you know, that I did want to point out is, and it could be a whole nother conversation, is about cost benefit analysis and whether that stands alone, and what's needed for that. But I mean, I can tell you again, anecdotally, sometimes the cost benefit analysis by itself is hard to get approval. I mean, because there are some intangibles, and then my anecdote there is the member company that I used to work for. It was hard for us, as part of a filing the first time around, to really let our commissioners understand the value of moving from the literal paper maps that we have in our distribution center to moving to something that's much more technologically based, instantaneous, and would move us away from having to hear from customers when they're out. Like just having the ability for us to transition and us being able to let customers know they're out, rather than looking at paper maps and not knowing how many customers are on a circuit, but just knowing where a circuit is. You know, the way that we helped get around that is having individual customer visitations to our distribution center, so they knew what we were working with. So then the second time we went around, the second time we went back to the commission, because we had initially gotten a denial, and we went back a second time. You know, when they had more context and they really understood from the distribution side some of the benefits, I think it made our case a little easier. And I know there are a bunch of questions, and we're looking forward to talking more about that. So I'm going to stop right there so we can have discussion.
Yeah, thank you very much, Shelby. I know that, you know, in my role at Evergy, I'm responsible for our overall products and services, or what we call energy solutions. And certainly as I think about each of your presentations, AMI meters, I mean, influence a lot of how my team is thinking about what products we're offering to our customers, and currently and in the future, and the interaction that we have with even with our distribution planning group. I am kind of curious, obviously with, you know, I think David, Yoni hit it probably pretty well around, you know, one, data is great, but even after you get the data, there are so many other pieces that have to fall into place. And even Shelby, you had mentioned, you know, the benefits. There's a lot of benefits around the AMI data, but there are also costs associated with it. In order for utilities to maximize the use of the data, there's additional cost. I think, as I think about that, to be able to offer their customers perhaps the apps, you know, that David had showed, the data analysis that needs to also go around making sure that we have the right people, right, to be able to do that type of work. How have you seen other utilities perhaps prioritize their AMI plan whenever they do present that to regulators? How are they prioritizing in that? And are they including other additional costs besides just the cost of the meter or the meter replacement? Are they also posing other costs as well as the benefits that might come out of putting those meters into place?
Yeah, you know, I'll take that, and again, I'll try to be very quick. But I would say, you know, rather than coming all at once with everything, because that number is really big and the whole prospect is overwhelming, what we've seen over time is that it kind of comes in stages. So maybe you come at first for the meter, then you come next for the OMS, or you come for the metering and the GIS capability first, then you come for the outage management system, then as part of a different filing, maybe you come for some of the customer solutions that you're hoping to get, and then maybe the last you come either in a different rate case for rate design, or volt bar, maybe more reclosers, things of that nature. But if you come all at once, I can tell you that the price tag, even though the time value of money means that you should come sooner rather than later, sometimes it's overwhelming, and the knee-jerk reactions to say no. So again, I think you just kind of, I don't want to say slice and dice it, but you kind of section it off. What do you need? Like, what's the foundational building block to get you to where you want to go?
Mm-hmm. Okay, thank you. And then as we think about, the AMI meter, it's for both residential and the business customer. What is the value? I feel like we talked perhaps more around the residential customer, but what is the value for the business customer?
Yeah, that's a great question. And you're right, we do tend to focus on the residential. It's a larger population. It's also a lot of times a larger interest, to the commissions in terms of what's the consumer value. But the business side of it, commercial and industrial, is very important. And a lot of it comes to scale. The problems that you may be assisting a residence with is 10 times bigger, with a commercial or an industrial, especially. If we're talking light commercial, it's very similar in a lot of ways to your residential. They'll have similar kinds of loads. If you're looking at a restaurant, again, being able to see real time, okay, the restaurant, my staff closed up, the manager can look, did they shut all the lights off? Is the freezer and the fridge, are they still running? Did they leave any other appliances on? Again, getting early warning signs that you're going to have equipment failure that could be very expensive, may result in an insurance case or anything, that is a huge benefit to the commercial customers, especially.
Thank you. And then Yoni, for you, you mentioned about the great amount of data. You had said the 50 gigabytes. I think that was for 30,000 premises. So obviously multiply that times 10 or so, as I think about some of the utilities that I'm more familiar with. Is the fact that you've got a lot of that data and then the modeling that needs to be paired with that. Is the modeling done more, do you feel like within the utility, or is that work that's usually tended to be consulted out, or utilities also need, because that's so much data, that they may need to seek assistance to prioritize what they're doing with all of that data for the modeling?
Yeah, thanks, Kim. That's a great question. I think as kind of I discussed a little bit about that. So there's definitely this increasing need for the tools and the ways to use the data. And there's, I think, several kind of facets to that. So on one hand, the software vendors that that are providing the tools for the utilities, they're definitely advancing their capabilities all the time to bring in this data, like the planning tools. They're increasingly having the capability to bring in the AMI data and use it in the planning tools in an integrated fashion. In the past, that was not possible or not really practical. So the tools are definitely advancing very rapidly. So there's that. But then there's obviously the need also for the utilities to kind of, first of all, understand, well, where do I need to use the data? How do I need to use the data? Where is the value of the data? It's not always valuable to bring in this huge amount of data and do these very complex assessments if you can get 90% of the answer doing a simple way. So there's need to understand like where the value really is. And then when there is value, to have those kind of methods and also the skilled staff to essentially do that. So definitely, like if you think about, say, distribution planners' role in the future, is going to, the skills that are going to be required from the planners are going to be quite different. There's going to be new types of skill sets that may be required. Things like working with large data sets, being able to script and automate certain processes and procedures and things like that. So there might be completely new skill sets also required from the utility staff.
Great, thank you. I know we're just about at time, and maybe I just have kind of one more question. I didn't see any questions that came across from our viewers, so I'll just maybe end with one question and for each of you to answer. You know, when you think about all of this AMI technology and data, what are some of the future applications of smart technologies that maybe have yet to be fully utilized or realized in the industry?
I'll start with that one. So I think a big one, and Shelby actually touched on it a little bit with the applications, the edge applications in particular, and then Yoni with the data. The amount of data that we're going to see moving forward is only going to grow dramatically. I can tell you the numbers he was showing there, you'll start seeing that amount of data from 1 meter in one day. So that is an unwieldy amount of data. So that's where you need the intelligence there at the edge, the AI and the machine learning to actually find something meaningful. Like when you're looking for something like the refrigerator, you don't want to do that across an entire population and identify 300,000 refrigerators, because the consumer cares about their refrigerator. So that's where that extra horsepower and intelligence right there is most important, because that's where the insights are most important. So then it's a matter of picking out the important things to send back to the operators and finding the information that's important to them.
Thanks, David.
Yeah. Well, to piggyback off of David, in our ideal world, as we move more towards electrification, and like, let's say you have an EV, you have some sort of storage, and you may have a PV or solar. I mean, getting all that information and more dynamic rates from our member companies, you would better be able to figure out or set timers about, when can you maximize your charging, but also reduce the company's peak. From a company perspective, again, the more granularity of data would better allow us to individualize offerings in a non-discriminatory fashion in order to maintain reliability, but maximize all of the interconnectedness that we're moving toward.
Thank you. And Yoni, any?
Yeah. I think as I discussed, there's so many applications from the utility perspective. I think, end effect, all of those applications are one way or another going to benefit the ratepayers and the customers. So I think there's a lot of applications being, in various phases. Some are, already deployed. Some are kind of being tested and demonstrated. Some are just being thought about, and I'm sure there will be applications that we are not really even thinking about now, particularly as David also talked about, that the capabilities of the meters are going to advance in the future. So there likely will be applications we are not even thinking about today.
Yeah, no, that's a great point. I was thinking about that too, right? I mean, we know what the technology is today, and it's only going to grow and advance for the future. So, well, I appreciate each one of you presenting today on your various topics. It was very enlightening to myself. I learned quite a bit. So thank you to each of you, and I will turn it back over to Josh.
Absolutely. Thank you all very much. As we've heard in the last couple of days, definitely technology plays a huge role. Information plays a huge role. So getting this better understanding of what is currently happening and the opportunities out there is fantastic. So thank you all very much for your participation and support.